Okay, so we've got to find, going through point 2, 3, and draw a little picture of it up here. 2, 3, so 2, 3 there. It's not very good. Try to do it more to scale. About there. So that's 2, 3, and that is point A. Gradient minus a half, so it slopes downwards like so. That'll do. And that is the line L. And so we've got, go to that gradient, that's minus a half, so y equals minus a half x plus c. And we've got to find c by subbing any point on the line, and we know the point 2, 3. As always, x is the first one, y is the second one, and so y, so that means 3 equals minus a half times by 2 plus c, that's minus 1, so c will equal 4, and so y equals minus a half x plus 4. So y-intercept, so it tells me that's 4. Don't know if I need it, but I'm going to put it on there. Could rearrange this to get a different thing. I could times everything through by 2 to get 2y equals minus x plus 8, and add x to both sides to get x plus 2y equals 8. But there's nothing wrong with the y equals mx plus c form. That's the first bit. Second bit, B. Show that the point with coordinates 2 plus 2t and 3 minus t will always lie on L. Well, this bit here, that's the x value, and that's the y value. So all I need to do is put it into this formula here. Okay, so I'm going to have x, which is 2 plus 2t, 2 plus 2t, plus 2 lots of y, so 2 lots of 3 minus t, and it says that that equals 8. What does that multiply out to give? 2 plus 2t plus 6 minus 2t equals 8. And that means that 8 plus 2t minus 2t is nothing. 8 equals 8, which is true whatever t is. So I've done that bit. Part C. So P is here, and P is 2 plus 2t. Bit of a mess. And y is 3 minus t. So that's P. Actually, P could be up here as well. So what have we got? I'll do it in red. It's got to come down here from 3 down to 3 minus t, so that bit will be t, or I suppose t is minus t, it would be up here at minus t, and that's 2, and this one here is 2 plus 2t, so that's 2t, so there we go. And it's told that the length of AP equals 5, and the length of AP, we've got that triangle now, so it's the square root of t squared plus 2t all squared, that is 5, so that's 4t squared plus 5t squared equals 5, square root of 5t squared equals 5, square both sides, 5t squared equals 25, so t squared equals 5, so t equals plus or minus the square root of 5. And now we got to find the value of t such that OP is perpendicular to L. So I'll do it in green, that's O, so P is going to be there. And again, the coordinates are the same, 2 plus 2t and 3 minus t. And we know, I hope we've got enough room, the length of a perpendicular. We want to find out where P is to start off with. And we know gradient of this, gradient of the line of L is minus a half. Therefore, gradient of OP equals 2. This is negative the reciprocal. So it's 2. So what's the gradient? Well, it's how far up it goes, and that's 3 minus t. So 3 minus t over how far across it go, which is 2 plus 2t, over 2 plus 2t equals 2. So 3 minus t equals 4 plus 4t. So that will be 5t on the right hand side is minus 1. So t equals negative 1/5. So I've found the value of t, and hence I've got to find the coordinates of p. So chords of p are 2 plus 2t, so it's 2 plus minus 2/5 basically, which is 8/5, and the y thing is 3 minus t, so it's 3 minus 1/5, so it'll be 3 1/5, which is 16/5. So that's the coordinates of p, and the length equals the square root of was x1 minus x2 plus the square root of the other one. So that bit will be 8/5 minus 0 squared plus 16/5 minus 0 squared. And so we get that. And then actually what we can do is we can take out the square root of 8 over 5 squared. And what do I have to times that by? I have to times it by 1 to get this bit. And this one here, I've got 16. So that's 2 lots of 8/5. So it's squared. So that's going to be plus 4. And that bit will give me the square root of 8/5 squared is 8/5 times the square root of 5. And that will be the answer. And that's that done.